Hello again. Our last speaker on this stream is Ozgur Akarasu, Head of AI and Data Analytics at Codes Digital. He'll present us the talk titled Business Value through XAI, Explainability Use Cases in Real-World AI Solutions. Ozgur, you may start now.
Hi everyone, I'm very glad to be here in this wonderful event. Today I'm going to talk about business value to XAI and give some example use cases how we implemented XAI solutions to real world problems. First of all, let me introduce myself. I'm Ozgur Akarasu and I'm working as the head of AI and data analytics in Koç Digital. My background is in industrial engineering, but my PhD is in AI and data analytics. I have an experience of 20 years in this field, and I'm still teaching in business analytics and value chain management in Istanbul Big University. Um, my company, Koç Digital, is a technology and solutions provider working in advanced analytics, in IoT solutions, and in data design and development. And since the foundation, we completed more than 200 projects, and we are working with companies, clients from 6 different countries, and more than 220 employees are working in Koç Digital. Today, the project I'm going to talk about is with a retail company in Turkey. They are one of the biggest retail chains in Turkey. And with them, we started to implement a supply chain digital transformation roadmap, which includes a demand forecasting project, auto replenishment and inventory planning project, and a store-to-store transfer optimization project. In this roadmap, everything started with demand forecasting because, as you know, forecasting the customer demand is very important for supply chain because you can optimize and you can transform all of the other processes related with the outputs of the demand forecasting. And in this case, we had to have an accurate forecast, especially for the short term, which is defined as 4 weeks by the client. And we also have to have a long-term projection for the customer demand for 6 months. And at the same time, the product portfolio of the company was very complex, and in order to cover this wide range of SKUs and wide range of channels, um, and also at the same time, in order to produce some accurate predictions about machine learning algorithms, we had to use uh, we had to use a complex methodology, a sophisticated method which includes all of the channels, all of the SKUs, and which also provides us some accurate predictions, especially for the short term. And while analyzing the data, we also saw that there's a very there are extensive variations in the sales trends, and we cannot explain those variations by looking at sales history. We also had to include some external data which tries to explain what kind of factors affect customer demand. Also, how does the competition in the market, socioeconomic dynamics in Turkey, and also product related issues affect the customer demand in the market. Therefore, we had to include a wide range of features which describe internal dynamics, at the same time external dynamics like currency rates, like inflation rate in Turkey. Also, there were some lots of features related with the COVID measures, which was a very new issue in 2020. We had to explain the sales transactions and sales trends according to those features. And at the end of the project, we covered 70,000 SKUs, which are, aggregated in 262 categories. And each week our models were producing 44K of weekly forecasts for 4 weeks and 20 weeks horizon on the store and location level. And our model included more than 200 tailored features like historic sales, campaigns, stocks, special events, calendar features, COVID features, current rate, etc. And we used Light GBM for short-term forecast and Facebook Prophet for 20 weeks forecast. And we calculated the accuracy and the power of the model by using an customized metric which we call WAPE, which is also measured on category and store level. At the end of the project for the test period of 6 months, our model performance was 74% accuracy, which is equal to 1 minus weight. And 74% on the average was a very good measure for the project because there were some product categories which were like 90%, 75%, or 85%, and there were some bad performer categories as well. But on the average, with the most important products, which also cover the sales volume, we have a good accuracy at the end of the project. And then we started to use the outputs of the demand forecast in various processes, supply chain processes, and everything was fine. We had the model, the models were trained on weekly basis. The outputs were produced on weekly basis. The supply chain team were using these outputs on their replenishment decisions, on their assortment optimization decisions, and when we just started to work with them closely about the outputs of the model, how they implement these outputs in their processes, we also started to receive some questions. And those questions were related with the model performance, the impacts of the model, and also the factors which affect sales. They wanted to know more about how the model behaves, how the model works, and the essence of the outputs. For example, like how the external factors affect sales, or what is the effect of campaigns for models outputs in different locations, or questions related with the predictions, like model failed to predict air conditioner sales in May. Why? Or why are the model's predictions are lower than actuals for location X? These questions were vital for them, and they wanted to get uh, answers as fast as possible in order to make some process-related decisions. And while trying to answer these questions, we started to make lots of analysis related with the model performance, related with the outputs, and our consultants had to spend, too much time with the data in order to answer those kinds of questions. And we started to feel there was an erosion of trust for model outputs on the client side, and we also felt a resistance to adopt data-driven decision making in their processes. That was not good, and we had to do something else. We had to do something else instead of making ad hoc analysis for those kinds of questions, spending too much time. We had to find a way to ensure that model outputs are, established in their way of working, and model outputs are helping them to make some data-driven decisions in their daily processes. And we identified the challenges in our case in three main categories. These challenges were related with the first challenge was related with the model features. And the models were very sophisticated. They were using more than 100 features on weekly basis, and it was not easy to explain the model behaviors according to by just like looking at the feature importance, because feature importance were giving us an insight. However, it was not explaining the model behavior in total. And secondly, there were some unexpected weekly deviations between predictions and actuals, especially for certain products and for certain locations. That's why we had to explain these deviations very fast, and we had to find a way to cure them in order to prevent, feature deviations. And the third challenge was related with some products and stores in which there was a shortfall of the model for some of for some products and stores. And in general, the models were underperforming, and we had to, deep dive to these products and understand why are they not learning the sales history, sales trends, and what to do with them. Including new features, excluding current features, or using a different kind of methodology in terms of modeling. So in order to cope with these three challenges, we identified that we had to do something else, and it had to be related with XAI, because XAI gives us a chance to understand how model behaves, how model makes predictions, and what is happening in these black boxes, which are very powerful to make predictions, which are very powerful to understand the dynamics of our trends, of our past data. However, as the business owners, we have to understand what's happening there. And explainable AI in our approach gives us a chance to accelerate AI adoption in on the client side, because once the business owners are feeling and they are unsure about the model behavior, model dynamics, then they can adapt themselves to using the outputs very fast, at least faster than usual. And also it enables accountability in terms of predictions, and also XAI provides a strategic insight about what's happening, in general, on the macro level. What kind of features affect the model performance in some certain regions or in some certain products. They can also produce some strategic insights about our channels, or about our product management uh, issues, or about our um, campaigns or prices as well. And lastly, XAI ensures ethics and regulatory compliance. Even though it was not a topic and issue for this demand forecasting XAI issue, however, in most cases, ethical and regulatory compliance issues are very important, especially in finance or in HR. That's why we developed an explainable AI solution on top of this demand forecasting module, and this explainable AI module included some tools and techniques for local explanations, which explain each prediction locally by using a local model that approximates the predictive model. We used sharp values for local explanations in order to make this black box model a gray model. And secondly, we developed a counterfactual analysis, which also included a set of features that should be changed in order to flip a model's prediction, which gave us a chance to explain, for example, why why that why the model predicted that product in that region like that. How what can we do to increase that? And we also applied some linear models like less, which is learning with subset stacking, and we tuned it with lasso in order to and compared the results with the uh, current model like GBM. And we also used some trees and rules in order to merge the optimization techniques with the linear programming, and produce some explain some white box models, which has a model accuracy similar to the black box models, but which makes predictions with less trees. So in this case, Shapley values and also the white box models outputs are merged and aggregated in an XAI dashboard, which is used by supply chain business owners. Our main target was producing some outputs for the business owners and I mean, transforming the XAI discussions from the data science ecosystem to the business ecosystem because we believe that outputs of the XAI solutions should help the business to understand the model behavior and also accelerate them and enable them to use these outputs in their operations. And these dashboards, which includes like model features by selection or model features importance by location, or looking at the importance of the features at their trend over time, or compare the outputs of the model which were trained in different time zones, or compare the product hierarchy and in different levels, in different locations, and look the feature importance on those regions and hierarchies. And also we use some visualizations to look at the most important features or the fifth most important features over time by season, by month, or by week. All of these dashboards were updated week on weekly basis and creating some output to the business owners to understand how their model making are making predictions and how they can help them to change these predictions to actuals. And at the end, the client supply chain team was able to interpret weekly model outputs and increase their decision-making quality for stock orders. This was a very concrete output, and it just created the business owners were uh, believing the outputs of the model and using the outputs in their daily decisions. And also it helped the business team to produce some strategic insights for their products and campaigns. For example, AC sales will prove that the effect of air temperature on different regions. They knew that, air temperature has an effect on AC sales, but they were able to see this effect on different regions and their differences. And also we were able to show uh, um, how campaigns affect sales in different regions and products. Their first hypothesis were just campaigns were affecting sales on country basis, but we proved that campaigns affect sales on different regions in different amounts. At the end of the day, their product availability in stores and automated order rate, which were very important KPIs for the supply chain processes, uh, um, are increasing, and we are still monitoring them to show what kind of improvements we made in these KPIs. But we show a short-term output like 10% decrease in their warehouse costs. And this was a proof of how XAI helped business to enable their advanced analytic solutions and use them as an analytics accelerator. And for the next steps, we are monitoring critical supply chain KPIs, and we are still applying some necessary revisions. And we are also trying to apply counterfactual explanations and rule generator and rule extractor modules to the XIS solution. And we believe that this XIS solution could be a model and a domain agnostic product for any kind of AI solution, any kind of AI model. Thank you for listening to me. If you have any questions, please do not hesitate to ask.